SpaceX is on the brink of revolutionizing the rocket revolution. Where Falcon 9 brought reusability, Starship Flight 12 is supposed to demonstrate Starship version 3, a rapidly reusable rocket giant, all while being mass-produced. Meanwhile, NASA is preparing for Artemis II, US astronauts departing for the moon. The wet dress rehearsal is next. But what if they can't get all this solved fast enough? Is China catching up? My name is Felix, welcome to What About It. Let's dive right in. Starship updates. Starbase is evolving. It's about to go through a profound change. What we've seen so far was slow testing to find a way to build the largest rocket ever built and to make it reusable. Partial reusability was achieved on May 27, 2025, when SpaceX reused Booster 14 after having previously flown on Flight 7 in January. And since then, Starship has been on par with Falcon 9 in terms of reusability. But SpaceX wants way more with Starship. They want a mass-produced, super heavy lift rocket that's fully reusable, not just partially. For this, they'll need several key puzzle pieces in place to complete the picture. One that's still missing is the Starbase Gigabay. Here are our latest images, both from Jordan and from Mauricio from RGV Aerial Photography. Especially Mauricio's top-down view shows that the bridges between the corridors are multiplying. The inner three rows now have interconnected bridges. It is still unknown if this is temporary. Any steelworkers in the audience who could shed some light? If they are not temporary, that means that full-size prototypes will only be handled in the road-facing section. This would mean a departure from the current manufacturing routine. Right now, segments are built inside the Star Factory, then they are rolled to a mega bay where they are stacked. During the stacking, a ship or booster doesn't move much. It gets stacked all the way, then it gets rolled out after everything is done. With these bridges in the way, that will be impossible. So if they are not temporary, SpaceX isn't just changing the design of version 3 starships and boosters, they are also changing the way they assemble them. It'll be interesting to see which way this plays out. The next big difference between Falcon 9 and Starship is that it's supposed to be fast. Not by airspeed, but by launch cadence. Take a look at this. It's SpaceX's air separation unit. It's right next to the launch site on the other side of the road, and it is now in an advanced stage of construction. Foundations are being built or done, plumbing is being installed. SpaceX has now begun installing larger components. Modules and large pressure tanks are being lifted in, and the structure is taking shape. It's targeted to be operational sometime this year. Time for me to explain what exactly this will change. There aren't any official numbers. By the looks, the plant can be categorized as small. Maybe 700 tons of commodities per day. This might sound like a lot, but we're talking Starship and SpaceX. A full Starship stack is loaded with around 3,600 metric tons of liquid oxygen alone across both stages. So 700 tons of output per day will give them a launch every 5 days. For now, this will be more than enough to cover both liquid oxygen and nitrogen needs for the Starbase tank farm. After all, we've been seeing a launch every 3 months on average since January 2024, so this plant alone should last SpaceX at least this year and next year if no dramatic changes occur soon. This only covers liquid oxygen and nitrogen. While combined, those are the bulk of commodities a Starship needs for a launch, there's also liquid methane. Methane liquefaction facilities would be a logical next step to address supply bottlenecks at Starbase. There's also another site nearby gearing up for SpaceX's demands. While there is no public statement from Linde, they are currently building a $100 million air separation unit at the port of Brownsville. This plant is much larger than SpaceX's small ASU. It is unclear whether Linde went in and took the risk without an existing contract, or whether this has just not been made public yet. They did state that the plant is being built to supply local space efforts, which only leaves SpaceX as a customer, but there is no official word yet from either Linde or SpaceX about a contract. Even if not, enough commodity output for a launch every 5 days would mean a 1,725% increase in launch frequency compared to the average in 2025 and 2024. That's enough. That's why I'm mentioning the air separation unit. Both Gigabay and ASU are working toward the next goal. They want to drastically ramp up launch cadence. The World Economic Forum once more hosted a gathering in Davos, Switzerland, and Elon Musk was among the guests invited for talks. During his talk, he covered a wide range of topics. The man is busy: Tesla, AI, Optimus, batteries, Grok, solar, spaceflight. He, of course, mentioned Starship as well.
Take SpaceX, for example, that SpaceX is about advancing rocket technology to the point where we can extend life and consciousness beyond Earth.
He said we can expect full reusability this year, confirming that the goal is to catch and refly a Starship upper stage, just as they've already done with the boosters.
Hopefully this year we should prove full reusability for Starship, which will be a profound invention.
He also confirmed another milestone SpaceX is working towards, which is directly connected to what I just talked about. He said that SpaceX aims to achieve a cost per pound of payload to space below $100 by 2027. Let's get this into perspective.
AI will be space, and that'll be true within 2 years. Maybe three at the latest.
SpaceX conducted 165 Falcon launches in 2025. It's another step up from the previous year, even though it seemed almost impossible. In contrast, the entire world had 330 orbital launch attempts worldwide in 2025, of which about 317 were successful and 13 were failures. So, SpaceX launched 52.1% of all successful orbital launches in 2025, and we're not even talking about mass to orbit, which is arguably the more important metric. Now let's assume it's 2028. SpaceX has achieved its goal of launching a Starship per day, the rest of the world has stayed at roughly the same output, and Falcon 9 as well. In that case, the world's total launch number would skyrocket to 682 launches per year, and SpaceX's share would be 77.7% of all launches. These numbers are just a guess into an uncertain future, but they show once more how big a change SpaceX, Falcon 9, and now Starship are for spaceflight. If you want to help us make even better content and fly more often in a helicopter, hit the subscribe button to stay informed. Like this video if it brought you value, and become a wise supporter for those extra heli flights. Be our fuel, chat with me, and gain more insights into the topic you love. Thank you very much. S39.1, SpaceX's current ship version 3 test tank, has performed another test at the Massey test site. This is round number 7. It's going through all the scenarios, it seems. Directly related to the ship pipeline, the PEZ loader was moved out of the Star Factory and into a parking spot behind the megabase. Ship 39 is certainly ready for testing, and it doesn't need Pad 2 for its round of static fire testing either. There's no official word yet. We'll have to wait for the road closure to settle the argument. What do you think? When will SpaceX finally start testing Booster 19 and Ship 39? I'm in serious launch withdrawal at this point. If you want to see how SpaceX is doing at Starbase from the air, just like Jordan does, visit redlineheli.com/Felix. $25 off for anyone using the link. The Redline helicopter team will show you the same Starbase views our photographer gets on his Starbase flights. Incredible views. While we wait for everything 2026 has to offer, one mission already stands above the rest: Artemis II. Before it can fly, it still has one major milestone left, but once that's done, this mission is cleared for something humanity hasn't attempted in more than half a century. This is not just another rocket launch, it's the moment we prove that humans can leave Earth orbit again and survive deep space. On January 17th, after sunset, the full-stack space launch system arrived at Launchpad 39B. The entire vehicle weighs about 5 million kilograms. That's one of the heaviest machines humans have ever built, now standing upright, exposed to the elements, and ready to be tested. As soon as it reached the pad, engineers got to work. They connected purge lines. Those are hoses that continuously flush sensitive parts of the rocket with clean gas. This prevents moisture, contaminants, or temperature changes from damaging delicate systems. It sounds mundane, but without this, electronics can corrode or freeze before the rocket ever leaves the ground. Next came communications. Engineers linked the rocket to the Launch Control Center, ensuring that every sensor, every valve, and every computer could communicate with the people responsible for keeping the crew alive. Then they tested the crew access arm, the iconic walkway astronauts will use to board Orion. This arm has to move precisely, smoothly, and safely because on launch day there is no room for hesitation. Attached to it is the emergency escape system. If something goes wrong on the pad, astronauts can jump into slide wire baskets that carry them hundreds of meters away in seconds. It's a last resort system, and the fact that it exists tells you how serious NASA treats the risk at this stage. Inside the spacecraft, things are getting personal. The Orion capsule and all rocket elements have been powered on, bringing the vehicle fully to life. This allows engineers to test how systems behave when everything is awake at the same time, exactly as they would be on launch day. Multi-day radio frequency testing is now underway with the Eastern Range. That's the network of tracking stations, antennas, and radar systems that follow the rocket from liftoff to orbit. If Orion can't communicate cleanly through this network, NASA would be flying blind during critical moments. Over the coming days, technicians will service the solid rocket boosters with hydrazine fuel. This fuel powers small control systems that steer and stabilize the boosters during flight. It is extremely toxic, which makes handling it dangerous, but without it, the rocket couldn't maintain precise control on ascent. They'll also load the final crew items into Orion, things like tablets, medical kits, and a remarkable experiment called Avatar. This experiment carries living tissue samples grown from the astronauts' own blood, and we'll come back to why that matters later. The biggest test still ahead is the wet dress rehearsal. This is essentially a full launch simulation without lighting the engines. During this test, ground crews will pump more than 2.6 million liters of supercooled liquid oxygen and liquid hydrogen into the rocket. These propellants must be loaded at extremely low temperatures, and even small leaks, sensor failures, or timing issues can cascade into major problems. The team will then run the entire countdown, stopping just 29 seconds before liftoff. That's as close as NASA can get to launching without actually leaving the pad. Afterward, they'll practice draining all the fuel safely back out of the vehicle, and that matters because in real life, launches do scrub. If NASA can't safely unload the rocket, astronauts could be trapped on top of a fully fueled vehicle. That's like sitting on a pile of dynamite sticks. If problems show up, minor fixes might be done directly on the pad, followed by another wet dress rehearsal. But if engineers uncover deeper issues, the entire rocket may have to roll back to the vehicle assembly building for repairs, then repeat the wet dress rehearsal again. That's why this test is so critical. It's the final filter before committing humans to flight. If all goes well, NASA will announce a firm launch date just days after completing the test. Launch windows are already defined, stretching from early February through the end of April. But whenever Artemis II flies, one thing is certain. This mission is extraordinary. So let's take a closer look at what this journey actually involves. On paper, the mission sounds simple. Fly to the moon, loop around the far side, come back home. Easy. In reality, it's a 10-day odyssey, covering 1.1 million kilometers, designed to push every system aboard Orion to its limits. After launch, the crew will spend their first 48 hours in a high elongated orbit around Earth, spinning around our world. This gives them the time to carefully test life support systems, power generation, navigation, and emergency procedures, all while still being close enough to come home quickly if something goes wrong. During this phase, pilot Victor Glover will manually fly Orion. No human has ever done this before with Orion. This isn't simple, intuitive joystick flying. It's precise, deliberate control of a spacecraft designed for deep space. The goal is to prove astronauts can safely maneuver Orion during critical moments, including future docking with lunar landers or NASA's planned Gateway station orbiting the moon. Then comes the translunar injection burn. This is the moment Orion truly leaves Earth behind. The spacecraft's European-built service module will fire its main engine, accelerating the crew fast enough to escape Earth's gravity. No humans have experienced this kind of departure burn in more than 50 years. Once complete, Orion will coast toward the moon for 4 days. At closest approach, the crew will pass about 7,600 kilometers above the lunar surface. That's close enough to capture incredibly detailed images of craters, mountains, and the far side of the moon, a region humans rarely see directly. At the mission's most distant point, Orion will be more than 370,000 kilometers from Earth, farther than any humans have traveled, ever. For nearly an hour, as the spacecraft passes behind the moon, the crew will lose all contact with Earth. No voice, no data, just 3 astronauts and their spacecraft completely alone in deep space. Then the journey home begins. After another 4 days, Orion will re-enter Earth's atmosphere and splash down in the Pacific Ocean near San Diego. The spacecraft will hit the atmosphere at around 40,000 kilometers per hour, faster than any crewed vehicle in history. Orion's heat shield must survive temperatures hot enough to melt steel, protecting the crew during the most violent phase of the mission. But Artemis II is about so much more than distance. Among its most remarkable payloads is the Avatar experiment. These are tiny thumb drive-sized devices holding living bone marrow tissue grown from each astronaut's own blood. For the first time, this technology will travel beyond Earth's protective Van Allen radiation belt. And that matters because deep space radiation damages cells in ways we still don't fully understand. By studying how real human tissue responds, scientists can learn how to protect astronauts on longer missions and potentially develop better treatments for cancer patients here on Earth. The crew themselves are also research subjects. They'll wear monitoring devices tracking sleep, stress, cognition, and physical performance. This level of data fidelity was never collected during Apollo, and it's essential for understanding how humans function when Earth is no longer close enough to rescue them. 53 years is a long pause. The last humans left the moon in December 1972 when Eugene Cernan climbed back into his lunar module for the final time. Since then, no one has gone farther than low Earth orbit. That is about to change. Artemis II doesn't land, but it does something just as important. It proves that humans can once again survive the journey beyond Earth and come back. And after this mission, the next time we go, we won't just be visiting. We'll be returning to stay, and this is what sets Artemis apart from Apollo. While these programs are sources of national pride for the US, and very rightfully so, another nation is working on its own share of groundbreaking space exploration. In 2025, China launched more rockets into orbit than ever before. 92 orbital missions in a single year, a national record and a jump of more than 30% compared to the year before. That sounds like China is surging ahead, but here's the twist. One single American company, SpaceX, still launched almost twice as often as the entire country of China. And that contradiction defines Chinese rocketry right now. Domestically, China's space program is accelerating fast. Launch pads are busy, factories are scaling up, and satellites are pouring into orbit. But when it comes to the most important breakthrough in modern spaceflight, reusable rockets, China is still chasing a leader that pulled ahead nearly a decade ago, and the consequences of that gap are strange. China could land astronauts on the moon before the United States does, even though it still hasn't successfully landed a single orbital rocket booster back on Earth. That sounds impossible, but it isn't. Going to deep space and landing rockets are very different challenges. China excels at building powerful, disposable rockets and running long, carefully planned government programs. What it's still learning is precision recovery, rapid iteration, and flying the same hardware again and again. The next 3 years will decide whether China closes that gap or whether it becomes permanent. Everything is accelerating now. China is targeting more than 100 orbital launches in 2026, roughly 2 per week. New reusable rockets are scheduled to debut from both state-owned giants and private startups, and massive satellite constellations are demanding launch capacity on a scale China has never had to deliver before. What makes this surge remarkable is that it didn't look that way just a year earlier. In 2024, China launched 68 rockets, barely more than in 2023. From the outside, it looked like progress had stalled, but beneath the surface, infrastructure was expanding and production bottlenecks were finally being cleared. Then came 2025. Launches jumped to 92, with the state-owned aerospace giant CASC carrying most of the load. CASC alone flew 73 missions and deployed more than 300 spacecraft, more than 80% of all Chinese satellites launched that year. And why am I mentioning this? Have you watched my video about mega constellations? China is about to flood orbit with satellites. Two enormous constellations are driving this demand. Guowang, a government-backed network, could include up to 13,000 satellites. Qianfan, or 1,000 Sails, plans more than 10,000 more. These systems aren't just about internet coverage, they're about strategic independence. To build them, China needs launches at industrial scales. And that's where the commercial sector comes in. Since China opened parts of its space industry to private investment in 2014, more than 200 space startups have been founded. 200! I mean, most will likely fail, that's normal, but a few have emerged as serious contenders. The most important is land space. Its Zhushe 3 rocket is China's clearest answer to the Falcon 9. It's made of stainless steel, burns methane fuel, and is designed from the start to be reusable. In December 2025, Zhushe 3 flew for the first time. It reached orbit successfully, but during its landing attempt, the first stage experienced problems during the final burn and crashed just meters from its target pad. Skadoosh! That might sound like failure. In reality, it's exactly what early reusability looks like. Landing a rocket is much harder than launching one. SpaceX learned this in 2015, Blue Origin learned it recently with New Glenn, and now China is on the same learning curve. Landspace plans around one Zhushe 3 launch per month in 2026 and has already won contracts to support China's mega constellations. The company is targeting launch prices slightly above Falcon 9, competitive, but only if reuse actually works. And that's the real gap. SpaceX first landed a Falcon 9 booster in 2015. 10 years later, no Chinese rocket has done the same. Not yet. And here's why 2026 matters. If China sticks a landing, it joins a very small club. If it doesn't, the gap with SpaceX, which is already flying boosters again and again, may keep widening. China is catching up, but only in some areas. The real race now isn't about who launches more rockets, it's about who turns learning into a routine. And that's it for today. Smash that like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store, our brand new Raptor emblem design, and countless others are there for you to explore. Click the card or the US or worldwide link in the description. And if you want to know how SpaceX managed to build Raptor 3, the new Starship powerhouse, and what makes it special, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode.